is starting. Um, okay, it's recording, not quite a notification yet. I got to do another quick thing. Uh, okay, now the notification should go out. Uh, Viral vlogs. Hello, thanks for joining us. Okay, I've got all the chat stuff pulled up. Notification should be out. I gotta tell the Discord group that we're live. Hi, Jashin. Okay, I'm gonna post the invite link for you guys. As usual, we're gonna give it about 15 minutes before we actually kick things off. Here's the Discord invite. It's where I actually get back to people and organize stuff from. I'm gonna tell them that I'm live. Yes. Okay, and there's the notification for them. System design hard. It's as hard as you want it to be. In that, uh, so how hard is it to do coding questions for like interviews? Like you can just do the standard leak code stuff for real interviews, and then you have coding competitions like leak code runs every week and code forces where you have these crazy DP problems. So I mean, it's a spectrum. Some of it's easy, some of it is very, very sincerely hard. And you can even, it just depends on how deep you want to go into it. It's just lies of assumptions. I mean, I mean, it's really easy to view this stuff as like bullshit. I'm not one of those people that views it as something that can be bullshitted. So like if you've ever worked at a big tech company and you've done a design document before, you know that it's not really bullshit. And the exact same stuff that you do in a design doc is what they're really trying to test you on in a system design interview. I don't view it as bullshit. And in fact, you can even do load testing stuff to simulate the different setups of these systems. Nobody does that yet. That's my long-term vision for this is I'd really like to do load testing of different approaches to show how different distributions of things will work under different setups with like a Kubernetes file or something and just like a little small army of Raspberry Pis or BeagleBone Black devices or even just EC2 instances and I just run it for like an hour and blow like $20 or $100 or whatever. Um, but I don't really call it bullshit. I don't really consider it to be bullshit. It's very easy to bullshit. So it's very easy to like if you're just doing system design for new grads, like half of the YouTube channels out there, or even I guess, some of my worst content, it looks like bullshit and it like kind of is, but like, if you actually implemented it, it's not going to work right. You're going to see there's issues. In the real world, when you have a bad design, you're going to see you're actually going to see these issues manifest. And so if you've ever worked at Amazon, you would know if you have a bad design because you're going to get in all these Sev2s and all these transient issues in prod. A classic example of how really bad design is going to manifest is that your DB is going to get high latency on its responses. You're going to start seeing these high latency because you're overburdening it. For example, if you're running scatter gather on something that is having like a really high volume of requests and you have a really bad scatter gather query, you're going to get really high latency on that. And then you're going to see that. And then eventually, if your traffic goes too high, you're not just going to have too high of latency. It's literally going to time out and it's going to become unresponsive for some of those queries. And so then you're literally just going to fail to scale. That's how bad system design looks, is that you literally fail to scale. And then you have degraded availability because you've received higher traffic than you can actually handle. I mean, so you're not going to really see this at mid-level companies, like mid-sized companies is what I mean, or stuff outside of FAANG because they're only going to get like 1,000 QPS or lower, and you can literally handle that off of a single PostgreSQL instance. So it's like you're not really going to see these really challenging system design problems that I am really interested in unless you're handling more than 10,000 TPS. Because lower than that, it's just PostgreSQL, unless of course you're doing like a really fancy analytical query. So like if it's something that requires a Spark job, or if you're doing something that requires a fancy key range query, you're going to have something a little bit. You're not going to get that full 10K TPS that I've seen quoted so much for PostgreSQL. You're going to get maybe 1,000, or if it's Spark thing, you're not even going to get 1 TPS if it's really that bad. And so there's other stuff you can do. Other ways you can have it manifest is that you, with eventual consistency, you'd have constraints being violated that you don't want to have violated. I've not been actually getting back to more questions, but you kind of set me off there. I get it. I get why you said this is what I'm gonna quote you. I don't mean to direct any hate towards you. It's a fair state. I would have totally sympathized with this so much back in like 2018 or 2019 before I really started getting into this. I'm just going to bold context. What am I going to call this? Rambling. It's a good. I like that you brought up this discussion, but yeah, and then it depends on what you're doing. Like, so in a system design interview, it has to be in under an hour, but somebody that actually would really agree with what you said is Steve from Life Engineered. He's a principal engineer at Amazon. He would agree. He thinks it's rather dumb that we do these system design. He runs system design rounds and he expects them to be done in 45 minutes, but like for the questions they ask, it's like completely unrealistic to have a full real world design for the problem that's fully fleshed out with all the features and everything. And he's like the interviews are a little bit unreflective of reality, and he likes to say the clubhouse is not the gatehouse does not resemble the clubhouse. Like, you go through the gate and then what you're doing on the job does not actually fully resemble what's in the interview. So yes, but also Kubernetes is a really great tool for spinning up infrastructure really quickly. So if I wrote a couple of services in Flask in just like an hour, just spin stuff up real quick, just write a really quick proof of concept, and had a couple of microservices, a database, a table or two, and I wanted to host them really easily, and I don't want to have to spend a whole hour trying to figure out how to spin it up on EC2. Kubernetes is great for that. And a lot of the SRE and DevOps stuff that you would have liked to not actually care about actually becomes like more, it's harder and harder to avoid it, I feel, as you go up the ladder a little bit if you want to be hands-on. So a lot of people in a principal engineer or staff engineer position that I've chatted with have actually been from a DevOps or SRE background or product support engineer. A lot of them have been from that background because they really know a lot about the constraints and the issues that you can see in some of these things. And they have a lot more hands-on experience with things breaking. And that's a lot of the experience that you need for getting good at system design is like the experience you have is like seeing outages, and then like, hey, this actually is not going to scale, it's not actually going to work. So people from these DevOps and SRE backgrounds actually tend to have some really great experience for higher leveled engineering positions. Actually, I have not been going through a lot of these comments. I need to get better at this. Please have low level design videos. There are a few on YouTube. I'm not very beginner friendly. I'm not very beginner friendly. There's a guy that does these. It's called Concept and Coding. I don't like his. I'm not a fan of his concept of his content. He does a lot of design pattern stuff. There's something. I have a basic familiarity of the Gang of Four design pattern stuff. I used to obsess over it when I was really early in my career, like 5 years back, and even throughout college, I obsessed over like I thought it was like the coolest stuff ever. And then if you start getting into functional programming, or you know a little bit about Lisp, what they say about how those patterns can be abstracted out is, I feel, very true. Anytime where you're writing a lot of boilerplate, it means that your language is probably not powerful enough. So patterns, I feel, is a little bit of a misplaced fascination in some ways, and then also it goes away as you go up the ladder, and so that's why I don't really care much for it. I'm not very beginner oriented, so that's why I don't really do that. I try to focus on the things that I wanted the channel for, and not spend times on the things that I don't want to have in the channel. Hi, regarding the problem, are we having the requirements? Again, by the way, I'm going to start it in like 2 minutes. that's why I'm not focusing on the problem quite yet. Are we gonna have the requirements that users will only see the leaderboard only at the end of the game? Yes. And even in between, I assume that even in the middle of the game, I don't know why you would really look at it in the middle of the game. Okay, I'll go over the requirements when we actually do start the video. I'll do that in like 1 minute here. I just want to skim through the chat to see if there's anything big addressed at me that I'm missing. And then we can go over the requirements. I'll have do a couple quick announcements. Go over the requirements and context for the problem. Let me finish all these other things I want to get through in the chat though. Please guide how to start FAANG approach for system design for a web app for front end and for back end. That's a general question about system design. I don't really do a general approach. I've done a couple of comments about that in the Discord channel. Feel free to ask me again over there. What are the prerequisites to start system design? I love this, but if you so you're new on the channel. So I have this great GitHub repository. It's github.com/ okay. Hold on. This thing. You want this thing. I have this infographic that has a list of a bunch of books. The high-level roadmap is that you want to read Don Martin's System Design Primer right here, Don Martin's System Design Primer. And then you probably want to check out Alex Shu's books. So this one and this one, I like two more than one. If you get through all that, you should start going through DDIA. I have a high-level roadmap in the Discord group. If you join that, just check out the README. I have it somewhere in there. Here's the link again in the chat. I'm trying to get through these as quick as possible so we can actually kick off the session. Please have low-level design videos. I haven't started yet here. I'm going to bring this to the front. Hi, regarding the problem, let's start that. Also, what is latency constraint that we have for this problem? Is it 2 to 3 seconds? So that's about the problem itself. What's the connection between staff and senior? I have some stuff about that in the Discord. I have some stuff about that in the Discord group as well. Just go to the README. No offense, I believe high level should be for. It actually does start at mid-level. Amazon definitely does ask system design for mid-level. Google asks for mid-level. Meta apparently asks for mid-level. They don't ask high-level design for mid-level in AWS. It's like basics are kind of expected for mid-level roles, for at least half of mid-level roles that I'm familiar with. Okay, let's go ahead and kick off this session though. Let's go ahead and kick this off. I'm gonna get one. Okay, we're gonna kick it off. So a couple quick announcements. Hey, I got a website. It's live, systemdesignfightclub.com. It has all of my files up on there. Here's the link again in the chat. It's not even, I just got it up like yesterday or 2 days ago. It's not even indexed by Google yet. So you guys don't even really have that. It's a little bit ugly, but it's a really, really easy way to go ahead and like check out all the files for the problems, like really easily gloss through it for just some specific stuff that you want to find. So yeah, check that out. Second announcement, hey, daylight savings time is happening. I was thinking next week. So this should only it was mainly only going to impact people in the US because it's going to shift everything back by an hour. So my original plan was, hey, maybe I'm just going to run these at 8:30 or 9:30 instead of 10:30. I'm kind of reconsidering that. I might split into 2 sessions, run it at like 9 a.m. and 3 p.m. next week. I'm still thinking it over, and I'll have I'll make a community post when I have it figured out. But just a heads up about that daylight savings time. Okay, so we've gone over the announcements. Let's get into the problem. Why is that thing? Okay, this should fix it. There we go. All right, we got that fixed. Okay. So these are the requirements I'm going to be handling. And so it should, do you want to see it right away, or is it okay to have a little bit of latency? I think I might have, oh, I didn't have that in a variation. Here, we'll have it as a variation. Immediate consistency versus eventual consistency. So for the person that was asking about how quick it should update and whether it updates in the middle of the game, I don't think it makes sense to have it update in the middle of the game. So the idea is that you would have you play the game, you win or lose, and then your rank updates after it changes your ELO ranking. So if you have it set up in a different way, where your rank as a player has changes from like points gained in the middle of the game, it's really easy to fix that. Here, I can go ahead and just start sketching things out a little bit. So you're going to have user playing game, and then you have like user viewing leaderboard. And then you're, of course, going to need to have the leaderboard view service. You're also going to need to have the gaming interaction service. So it's like the game service, which might even have, say, gameplay service. That's a little bit more accurate. Which might have WebSockets or something. And then this one's going to be the leaderboard viewing service. Hold on. That was really ugly. It was bothering me. So this is going to be for reading, and then this one's going to be updates. So you're going to have, so like as you're playing, you might have some updates that you're sending over, some interactions that will result in some like points scored or something. And so you're going to have, you would have, your player, details DB, and you're going to update your maybe it would so like if you're continuously changing the elo rank of your player, your account throughout the game, that would mean that just you have these happening throughout the duration of the game rather than just once at the end. So your elo rank is going to update every single time that one of those events happens during the game. That would update your elo rank. So it just means that the only adjustment you have to make for this is that it happens throughout the game rather than just as a singular thing right at the end. But I'm going to be doing this just in terms of one update right at the end of the game. But it's very easy to shift this so that it can work in the middle of the game rather than only at the end of the game. And of course, people are going to be able to view your rank throughout the game because there's no reason why it should be locked throughout the game. You can just see what it was prior to, and it just means that your rank as a player is just kind of like stale, you could call it, throughout the game. Okay, let's talk about some context on this game, some resources for this that I went over. So this is based off of the Alex Shu Volume 2 coverage of it, which he uses a Redis sorted set for. It has a skip list thing. It's really cool. I'm going to go over one small thing that I think is missing. So he uses Redis, which is in memory. And so then if the server gets power cycled, it means you lose everything. Also, RAM is rather expensive. We're going to go over it, but I just think that you should maybe persist it in DynamoDB or something, or just any kind of persistent storage prior to sending it over to Redis. That's just my 2 cents, is maybe you should persist it so that it doesn't break everything if you do a power cycle and you lose data. So DynamoDB, of course, also has some cool documentation on this. They took a shot at it. They recommended using a global secondary index, and people have asked me about that before. And I'll try and illustrate this concept. We're going to cover it as one of the variations. It's going to be an approach that covers global secondary index. In that it's a good idea when you have really high read volume and you're very heavy on reads. You're very read heavy. Outside of that, if it's balanced read and write traffic, it's not really a good idea. I'm going to illustrate why when we get to that. And then so this one also recommended this one. This is what I thought was the original documentation, but it actually recommended using this thing called RockSet, which is real-time analytics. And like that's not what we're looking for. That's not actually what we're looking for. I was like, I don't remember seeing that in there. It's a third-party database it was recommending, and it looks similar to Flink. So real-time analytics, that's like Flink or Spark Streams or I forget what the name for the built-in AWS service is, but AWS does have something that is they do have their equivalent to Flink that's built into the AWS service. I just cannot remember the name of it though. It's like nobody uses that. God, that's bothering me so much, but I know there's an AWS service for that. So this one was recommending RockSet, and I was like, that's peculiar. And then we have this one. This thing was recommending the global secondary index. That was funny. That was like I said, it's good if you're read heavy, but I was like, that's rather there it is. Oh no, they actually had at least two goofy things here that I thought was weird. Yeah, I recommended using a global secondary index. Or was it in the when it was it in a different spot? Let me see this. Yeah, a leaderboard can be implemented with a global secondary index. That's some dangerous advice. So this stuff's written by what's called a solution architect. Here he is, a senior NoSQL specialist solutions architect. That's not an engineer. That's not an engineer. That's actually a salesperson that knows how to speak engineer. And so it sounds like he might know what he's talking about. He doesn't. It's completely different. That's who writes these articles, and that's why they say that goofy stuff. So the first one was that. There was actually a second thing that was really funny. It was this. End-to-end relationship modeling, using a partitioning key and sort key as a primary key. You didn't even really need to say that. I guess the sort key is optional. You didn't say how to use the sort key in this case. And then he said, and a global secondary index. No, you don't. You don't throw a global secondary index at it whenever you do end-to-end modeling. That was fucking atrocious. That's a solutions architect wrote this. In another case, somebody I heard of a solutions architect. He was like hearing Snapchat has this social graph thing to model its user database, and so they have this vendor from AWS, and he was like, oh, social graph. How about you use a graph database? That's bad. That's bad. These people don't know what they're talking about. So just yeah, we're going to go over it. There is a case where it is smart to use a global secondary index, but in this problem, 90% of the time, it's probably going to be a pretty bad idea. So now we've gone over all the resources for this, and I'm going to, show you what those look like as a graph. Our actual requirements are going to be ELO's updated at the end of the game. If you want it throughout the game through multiple events, like I said, it's rather easy to modify. You just have several events throughout rather than one at the end. And you're going to see it at the end. We're going to cover both immediate consistency and eventual consistency. Let's go ahead and keep filling out the graph. Michael is saying you have something like this, and then you can have a database for Redis, the actual rank data store. It's the player rank data store, and this is just going to be a read optimized view. That's all it is, and you're just going to update it with a DB trigger. It's doing like change data capture, so they have roughly the same information, but it's just going to be a read optimized view. And so then when you're trying to view that, the read comes in, and then you do your query over here for it. You get your result back. Okay. What was the first approach that I wanted to do? Wanted top K players. Oh, okay. So there's also either the top K players, just the top 10, as in like the top 10 players out of 20,000, as opposed to your specific page, which is like if you're at rank 10,387 or something, you're just going to be way further down. That's going to really be bad for scatter gather. So first we're going to do the top K approach. So let's say that you got your game and you're doing just like an ELO style thing, which is actually what chess.com or there's the top chess website uses ELO. I think onlinego.com uses the ELO ranking. LeetCode uses ELO ranking for the weekly contests. It's pretty standard for how you do player ranking systems. And it's not, all you have is you got your player ID. So we're going to use my username from on Discord, ubidesu, and we're going to say that my ELO rank is like 1000. My ELO score, it's not my rank. This is like my points. Maybe we should call it ELO points, not ELO rank. I'm going to say that I have 1087 points. And then we want to get my place in the player data store. So if you're doing the Redis sorted sets thing, that would be over here. I think we wanted to first do the top K players approach though. So I was doing a quick sketch with this diagram. We're gonna redo it for the top K approach. So you have this, and let's say that you want to get the top 10 to 100 players. And so you can just do, you can even just do, one of them is, so scatter gather is not horrible here. It's not great, but it's not horrible in this case. If you get to around 10,000, where it's like the my page thing, where it's looking at players that are in the top, when you're looking at players around like the 10,000th rank or something, then it is pretty awful. But in this case, you could do scatter gather. That's a little bit naive. So the query is going to look a little bit like select star from players where, I don't think you have a where, you just do order by ELO points, and then you do limit 100 or limit 10, depending on what the K is. So that's going to be a scatter gather query if you're doing, so that would be, in this case, you would have this one as the partition key. And this one would be the sort key. And this is a little bit naive. You can definitely do something a little bit smarter where you can have a cache of the top 10 to 100 players, and you just store those top 10 to 100 players. And so this one's a little bit naive. If your query volume is like under 1,000, if it's under 5,000, I guess is probably a fair cutoff. It can handle it to 10,000 queries per second, I believe, usually on like one node. So if it's above 10,000, this isn't going to scale very well. Okay, I see 2 questions in the chat. I'll get to those in a minute or two. I just want to go ahead and go over a less naive approach. So this one, at some point, it's going to fail to scale because you're doing a scatter gather hit still. It's not so bad because you're not doing 10,000 records that need merged over the network, which is really bad, but it still is doing a scatter gather, which is going to have, I believe, a bottleneck at some point. So we're going to go ahead and look at a somewhat improved approach, which is where we're going to go ahead and have a cache still, and it's only going to have the top 10 to 100 players, and it's going to be on one machine, or it's going to have replicas, what you can do. So you could have player details, it's a cache, and so it's going to be the same exact stuff getting replicated, but you only replicate the top 10 to 100 players. Or you could, yeah, you can do the top 100 players. So you're only doing you're only going to pull in top 100 players records only. You could have a a Lambda function or something, and there that does the logic for handling whether or not it meets the top 100 players threshold for the ELO points. And then you're just going to be running your query against this. And since it's less than 100 records, you're not doing scatter gather. And what you could even do is you can have replicas of that cache. And so it can be something like Redis. You can say Redis, for example, or memcached. And this is if it's above that threshold where the scatter gather is becoming rather hard to scale. If it's under that threshold, this is going to be just fine. But once this starts to have some scaling pains, you can go ahead and switch over to cache. You can start with one node. If it's higher than that, you can throw a couple of read replicas at it. But that's really all these are. Is even with one node, it is still basically just a read replica of the other, but with like a much more limited number of records that are actually being held by it. It can just be off of either. You can just go ahead and throw a load balancer in front of these, I believe. And then this would be able to query any of those nodes in it. DynamoDB, I think, internally has this component called a request router that figures out the proper partition, the proper machine that has the partition that you want. Yeah, and this is, yeah, I guess it would, you don't even have a limit on it, I guess, anymore if you're going to do that. You could have these co-deployed onto the services actually. So that's actually another idea, is that you could literally have it doing CDC directly onto horizontally scaled out machines that have the Redis cache co-deployed onto it. I've literally never seen that before, but I mean, that is totally a thing that you could do. I'm going to draw that and then I'll get to your questions. So I swear this will be my last diagram before I get to your questions. Sorry. And this one is better for high scale. We're going to say 10K plus QPS scale. And then idea for alternative idea for high scale. And we're just going to have this thing horizontally scaled out. So I'm going to make a couple of copies of that like this. And we're just going to have these. I'm going to shrink it. Like that. And we're going to have it like this. I want to actually draw that Lambda function that I was talking about. And so now it's local, and so it doesn't even have to go over the wire to hit that Redis cache. And we're going to have Lambda functions. So we are doing our CDC. It's going to go over to the Lambda functions. And then that one is going to copy it out to all of these. I feel like that's a thing you can do. It's an idea. Yeah. And now I'll get to your questions. Okay. Is it Amazon Kinesis for, hold on. Is it Amazon Kinesis? So Kinesis is basically like Kafka. That would be a broker. That'd be a message queue. You're talking about the real-time thing. You were talking about the real-time component I was trying to figure out. I don't believe it's Kinesis. Now I'm just totally I'm trying to look it up. I don't think it's Kinesis. I don't think it's mm, yeah, I don't think Kinesis is just like Kafka, isn't it? I don't think that that's the right one. It's really subtle. I don't Yeah, I don't want to worry about it right now. I'm sorry. Thank you for trying though. I appreciate it. I seriously can't. I think like usually if I was gonna actually draw it in an interview and I had to name a real-time analytics component, I wouldn't even name the AWS one. I would just name Flink because Flink is so much more standard, or even Spark Streams or Druid. So a lot of the much more standard real-time processing things are like I said, Flink, Spark Streams. I believe Druid. It's what you're looking for is a thing called count min sketch. And I don't know how it works. Stanley Chiang has a really wonderful explanation for how it works in his book. I'd recommend that. Otherwise, it's there's even a Wikipedia article on it that you could check out. Initially, it seems it would be read heavy, but if we assume like 10K games finishing each second, then we might have to update the board frequently. Thus, this will be very write heavy. Well, so it's write heavy as like how does the write volume compare to the read volume? So if it's 10K games finishing per second, that would mean 10 writes per second. But then if you're also viewing, if it's also showing you that leaderboard every single time at the end of the game, which is how Alex Shu described it in his prompt for this problem, is that the assumption was that on finishing the game, it shows you a leaderboard screen. It also says game over on it, kind of like I had in the thumbnail for this video. It was like at the end of a game, it's going to show you this, and instead of leaderboard, it might say like game over, or it just shows you this at the end of every single game that you finish. And so then it would be balanced because every single time that you finish the game, it also would show you the leaderboard, which is a read. And so then it would be balanced. But if you didn't want to have it, if you don't want to show that screen, you would be right. You'd be right that there is one case where it would become write heavy. I guess that would even be a fun variation is to talk about if you don't show that leaderboard right away, and then the write volume the read volume for the leaderboard becomes really, really low. And so you wouldn't want the caches at all. This would be a very smart approach if you're gonna do actually okay. Ah uh It'd be a smart approach if you're going to do just the top K players, but if you want to show player number 10,597, then that scatter gather is still going to be really expensive, is the issue. And so you might want to try and do some kind of caching trickery where you're doing this offline analytics thing every so often, like every 15 minutes, and then you just have this like cached copy of that table that you're letting them go off of. But then that would of course be eventual consistency as well. And so it's like I feel like the Redis sorted set still might be kind of a good idea for a read optimized view for handling that edge case of the viewing player number 10,567. You know, yeah, but so that's a different variation is if you don't want to show the leaderboard every single time, and then the read volume is going down to like 1,000 or less. There's a couple of comments in the Zoom chat. I want to get to those too. So I've got 4 comments that I want to get through before we talk about any more approaches. Okay, so you're also a little bit more new. Change data capture. That's a really standard term. It's okay. I think Martin Kleppman might have brought it up once in his stuff. There's something that's built into PostgreSQL. I heard like there's some kind of extra thing that I think integrates really well with PostgreSQL for CDC. I'm going to look it up really quick. Really? Can I not find anything today? I don't even know what it's like a plugin for Postgres for CDC. Debezium. So that's another tool for it, but for I think DynamoDB, I think it's like DAX. Or you can just use DB triggers, and a DB trigger is just it's built into your database. It's a thing that goes off whenever you do a write operation. So otherwise, I think you can kind of like roll it yourself. Yeah, Dynamo I'm pretty sure DAX is like a really, really super solid thing for it's really nice for like sagas and change data capture, I believe. Yeah. Needs to be uploaded after they stay up. They stay up. Yeah, no, this is gonna stay up. I don't take any streams down. I sometimes try and roll them over into the videos tab, but yeah, no, this will stay up. Don't worry about that. It's yeah. Same link too. It doesn't change the link after it goes to like offline recorded. I'm looking at the Zoom comments now. Is the Redis is costly solution for even 10K events? So it's like so Redis requires RAM. RAM is expensive. RAM is expensive. But I mean, if you only have like if you're able to get away with like just one machine that has like 16 gigabytes of RAM on it, costly is relative, and in that case, it's really not that costly. And so that's why I was saying that, like, if it was write heavy, like that one guy was saying, then switching over to that other approach with the actually it just looks like this. I could have just copied that diagram instead. That was a mistake. I'm going to copy that one instead. So if you're just doing the this is the your page approach. Let me zoom in. You guys can't see what I'm doing. So this is the your page variation. Super low read volume. So this is from what if it was write heavy? So you can have that Redis cache and then you just have like one node of it running. Hopefully if you can actually fit like 20,000 players in it or whatever. We can do some quick math on how much that would take. Is like, what if it's I don't know, 200 bytes per player record, and you have 20,000 players, or what if it was even like 50,000? And so then we have that one would become 100,000 bytes times 100, 1 million. That would be 10 million bytes. I said, oh yeah, bytes. Okay, yeah, I guess that's okay. 10 million bytes or 10K kilobytes or 10 megabytes. Holy crap, that's really small. That's like really small. I don't think that's right. Oh my God. What if we had 4 whole gigabytes and we had so what if it was like 4 gigabytes and it was a whole I don't know, 1 kilobyte per player record. So then that would be what, 4 million players it could support? That's a pretty fair amount. I don't it's I mean that's probably I mean I think you can have up to like 100 million players in some cases, and then that'd be like around 25x So then you would need, so I mean, if you had 100 million players, would then require 25x of this. That's 100 gigabytes. That's kind of pushing it for one machine. You can do that with, I think you can actually get a machine that has 100 gigabytes of RAM provision to it, or at least like 48. You can get at least 48 gigabytes of RAM provision for one machine. These are not consumer machines, but like you can definitely get a server on AWS with like 48 gigabytes of RAM. I kid you not. But like if you have 100 million players, you're probably gonna get read volume high enough that you're gonna want to go ahead and start partitioning the cache. And then you would fully justify your Alex Shu approach of sharded Redis on multiple machines and the very cool trick that he's doing on it. Went away for a little while, so not sure if, hold on. It might have been Athena that I was thinking of. I don't know. Wait for a little bit, not sure what the real-time discussion was about, but found, is this the rock set thing? The featured partners, I think, are like third-party services, not like built-in ones, I believe. Kinesis data analytics. See, that's third party. That one's third party, I believe. Does Kinesis actually have stuff built directly into it now? That would be nuts. I wouldn't be up for that. I don't know if I would trust it is what I meant. Is that just the same link? Yes, it is just the same link. Well, thanks for your find. Yeah. For ELO, do we need to discuss the implementation of how ELO works? No, I don't think so. I don't think we need to do exactly how ELO works. That's something people can look up on their own. It's like a discrete transformation. You just do like a one-time update of the ELO points of the guy, and it doesn't like degrade while you're away without interacting or anything like that. And yeah, you are able to adjust it for multiple players, and I know that leak code does that. Implementation would be fairly straightforward, but the leak code, it's. I know they do something wild. Okay, we can move on from that. I think we should just show the current in-game rank and update each player's ELO. Yeah, that's why I'm currently sticking with the one-time approach at the end of the game. But it's very easy to modify it to work for like updating throughout a game or anything like that. Use Redis, it's possible we face downtime, lose leaderboard, even. Yeah, that's why I was saying that we want to have this first database should be, you can use DynamoDB, or if it's low scale, you can do, again, if you can fit on one machine, you would be able to do PostgreSQL, and then you could use Debezium instead for the CDC triggers. What else might make sense? I mean, if you're at Google, they throw Spanner at everything, and so I mean, Spanner's kind of like an option. I don't know what else I'd even consider throwing at this. So I think some people are unhappy that I keep using DynamoDB everywhere, but I like, what else are you going to use? I mean, PostgreSQL, sure, but then if it has to be if you have to do partitioning, then you have, manual partitioning, which is a huge headache. So really, 256 gigabytes. Is that hard disk, or is that like RAM? one is it? Memory optimized. There we go. Jesus Christ. Oh my God. Oh my God. What is this, like one machine? I don't think this is real. Oh, I think that's from like the AMD Ryzen cores. I thought those only went up to 100. Oh, you can get dual core though. You can get a dual core motherboard, and then that kind of makes sense. I don't know if you can actually get 20,000. This just doesn't look real to me. I'm gonna move on. Thanks for finding that though. Um, I want to keep covering some other stuff. I want to okay. So I went through top K approaches. Um, your page, we talked about it briefly. We didn't talk about the full Alex Shu approach. I did go over scattered gather over here. It's bad on the low part. If you were to do the your page approach though with 10,000 records, it's bad because it would be fetching thousands of records off of each of the partitions. So I can kind of go over that, and then we can look at, yes, we need global secondary index, Alex Shu's skip list, and we're pivoting towards the your page variations. These are all from the top K variation. And so now we want to talk about the your page variation. And we're going to look first at the Dynamo. So if you have, so this is if it's like DynamoDB, okay, so your partitioning key is still that, and you're trying to find, you're trying to get your player's rank. There is no limit on this. You have it ordered by that, and it's partitioned. So you have partitioned. And so it's gonna update your partition, but we're trying to figure out what the what your rank is on this. And so it's not ordered by the points. You actually like can't order by the points very easily either. If you did partition by points, and what happens if you do partition by points in DynamoDB? Why is that not even a good idea? Because you can get a hot partition. For starters, you could get a hot partition if you did partition by ELO points. And then also, the issue here is that you would still need to count all the way to where your current ELO points spot is. You can't keep an auto rank there because people are hopping around in the ranking system. So yeah, I'm gonna need to start another thing. So you have like player one at like we got all these players here. I'm going to try and explain this as quick as possible, but I know this is, it's kind of important to explain this. So you got player four who's at, let's say, 893 points. They just finished a game. This guy's at 914. This guy's at 923. So this guy gets enough points that gets bumped up to 925. So he goes over here. We'd have player four new position. So he becomes spot 2. This guy gets bumped to 3. This guy gets bumped to 4. So you can't do you can't use like an auto increment. And so like the issue with trying to do anything where you're sorting by elo points instead of by username is that like you still have to do a full big O of n scan. And you actually kind of have to do that too. Over here, you're still doing a big O of n scan all the way down to spot like 10,000. So this is your page variation, and it's approach 1. Dynamo, DB, scatter, gather. Oh, it's going to maybe name it Elasticsearch. So you actually can't use Elasticsearch because it is not supposed to used as a system of record. You're not supposed to use it as a primary store. So I had said / Elasticsearch, but I just realized you can't use it as a primary store, so it won't actually work there. You can have it like downstream as a secondary store over here. But again, you're still going to have the same issue of that scatter gather. And this is a local secondary index to be specific, because we're going to later go over a global secondary index. So right now it's a local secondary index, and so you get the scatter gather. So you're fetching like 10,000 records. It's like 10,000 plus records. And you can't, because of this thing that we talked about, you can't guarantee that, the highest points are going to be on this partition, mid-range points are going to be over here, lowest point player is going to be over here. They're just scattered throughout. So what that means is that you're going to be doing a query against all these machines. You're going to have to hit all of them in order to try and figure out your rank. You need to fetch everybody that has a higher rank than you. And so each of these is going to be returning thousands of records over the wire. Maybe it does something a little bit smarter, like under the hood, but it still needs to figure out the position like over the wire, and there's not a super efficient way to do that, and this is called scatter gather. And in fact, if you try and do an Elasticsearch query if you've ever done pagination with Elasticsearch and you try and find record number 10,000 plus, you're going to get these really massive latency spikes. And it's because this is what you're doing. The first couple of pages on scatter gather with Elasticsearch are going to go fine, but like if you've ever noticed that you get these huge latency spikes and go up to like page 100 plus, it's because this is what you're doing. So this one is naive. And now we can talk about what those clever guys at AWS had the idea of doing is a global secondary index. So global secondary index it's really fancy and it's cool, and I really wish that it had more practical use cases, but it just usually doesn't really pan out that well. I know there's more comments in the chat. I'll get to them after I go on a diatribe or whatever about global secondary index. So with a global secondary index, you're able to avoid the scatter gather. Because the whole thing is ranked, the whole thing is ordered in such a way that each one like has, I heard you're supposed to treat it like a separate table entirely in DynamoDB. So like the global secondary index, each one is kind of like a separate table entirely. Maybe it's even async, I don't know. But you're able to answer it off of like one partition apparently. But the expense of this is that it results in it's scatter gather on the right side. So when you're doing the write operation, you actually then have to update that record on all of the machines. every machine has the context on the sorting of all the records. So now you just have scatter gather on the writes, to my understanding. And the reads are supposed to be really effective. So it's great if it's read heavy. If it's read heavy, this is going to be a minority use case. And so then you can do that kind of thing. But that's usually not going to be the case, particularly if you're doing the your page variation. If it was the top T variation, then there'd be higher concentration on specific records because it'd be the top 100 to 1000. But when it's under your page variation, a specific page way down in it is not gonna, it's not gonna be very read heavy. So let's go ahead and capture what I've had to say about it in the notes. Great for read heavy scenarios. Otherwise, the scatter gather on the write operation is too expensive. Okay, let's go ahead and get through some of these comments. This might be a slightly naive understanding of how it works, but I understand that the write operation when you're doing a global secondary index is very expensive from what I've read. Okay. Easium registers itself as a DB replica, monitors the write-ahead log, and uses Kafka Connect to push changes to Kafka topics. Downstream services have to consume from this topic to be up to date with DB changes. I didn't know it was using Kafka. That's crazy. Thank you for sharing that. I did not realize that Debezium had this whole Kafka thing going up internally. That's really crazy. For your page approach, I think it would be better to partition based on the ELO points. Easier to do key range query in that case and get the 100 guys around me quickly. I think it might have a hot partition issue. I probably don't understand it completely, but I believe that there's some kind of issue with partitioning by ELO points that results in some kind of issue with hot partitions or something. So Alex Shu's Redis thing does do that. Alex Shu's Redis thing does partition by the ELO points, but it does a skip list. I think the thing with the ELO points, if you're doing it as the partition key, you'd have to sort by it. And then the issue with that is that you'd have these things hopping around a lot, and it doesn't work well with B trees, I believe. I don't think it works well with B trees to try and keep them all. Well, so you can keep them sorted. But in order to find out the index, you'd have to do this like big O of n query, to my understanding. I don't think there's anything augmented about a B tree where you can figure out the rank of a specific record really quickly. So I think that would work with it partially works. I think the rank operation would still end up as big O of n. That's what the issue is. And for Redis sorted sets, you're able to do it in big O of log n. You're definitely able to do it in log of n with the skip list from Redis sorted sets. I don't think you can do it with B trees. Okay, but one thing that ELO points would be changing. I'm gonna make that quick note with thing that ELO points would be changing, thus not sure if that's a good. Yes, yeah, that's why it's a bad idea, is that it's because you kind of like need to have the rank, you need to know the count of each of these players. So when that one comes in, so like I said, you would have this guy's at 1, this guy switches from, it was at 4, now it becomes rank 4. So it just slid in there. And then this guy went from 2 to 3, and this guy went from 3 to 4, which is so, you'd have a whole bunch of every record between its old position, its new position would need to have that number in it. You would either need to increase the number there, or you would need to do this big O of N scan and like count it up all the way to where the current rank is. I don't believe it works in log of N time though. I've said that like a half dozen times. I'll move on and stop harping about that. If we are considering a game which has players across various geographic zones, should we not consider using a distributed cache system? Well, it's I know what you're getting at. I know what you're getting at. Maybe this is a good spot for maybe this is a good spot for switching over to Alex Shu's coverage. So Alex Shu had this clever idea in his book to instead of using a global secondary index, he wanted to use Redis sorted set. Let me zoom in so you can actually see. So instead of DynamoDB, it's using Redis, and it has this is the key object, or it's the object thing, and then this is the value, and then you have the value as this one has the sorted set skip list over it, and you're able to he does have it partitioned by the ELO point, so it is also the partitioning key for you to have multiple Redis nodes here. It's manually partitioned Redis. And so you're able to figure out the size of a whole Redis instance in big O of 1 time. It just knows how many, it keeps metadata on the number of records in it, and you just find it in big O of 1 time. And you know the range of it, I believe. You would know that this is the people that are between, it'd be like 9,000 to 8,000 ELO. And you'd have like 8,000 to 7,000 ELO in the next one. And we're just going to do one more. Sorry, we're just going to do one more. 7,000 to 6,000. And so if you had 6543 ELO, you would find the size of this in big O of 1, find the size of this in big O of 1, and then you would do a log of N check on this to find out what your rank is within this database. So it's kind of scatter gather, but these queries should be really fast, which is great. And Redis is pretty fast. It actually is able to handle TPS of 100,000. If you have more than 100,000 TPS for your database queries, if your QPS is higher than 100,000, I think you're kind of shit out of luck here. Yeah, I don't really know what to do about that. But as long as it's lower than 100,000, this should work pretty well. And that's Alex Shu's approach. Let's go ahead and so like, what if it's geographically distributed though? What if it's geographically distributed? I think, okay. I have two things about this. Is one is what somebody else had brought up is data loss possibility. What if your Redis instance has the power cycled? I think that's pretty important to handle. And then the other one is geographically distributed. So we're going to first handle the data loss. So like I said, it's Redis. Using this as a primary store is like super dangerous. So this is Alex Shu's variation. We're going to make a quick copy. And we're going to have a primary store thrown in at the front of it of... So again, we're going to have our player details DB thrown in. And then you're going to do CDC to these other things for the record. And you might need to have a Lambda function in there instead to handle some extra business logic for keeping the record in the proper partition. So if it hops between partitions when the ELO rank is updated, you might need to have a Lambda function for handling that properly. Yeah. So this is, we're going to call it approach 3.2. This is adding better redundancy, making the service more reliable. And then let's talk about geographic distribution now. So we got this, we got our Redis instances. We want to have it geographically distributed. So we're going to have our United States viewers, we're going to have our Europe viewers, and then we're going to have our Asia viewers. Let's go ahead and label them. So this one is going to be United States. We have EU area. And then we have our Asia area. Instead of this, you have your Redis thing. And then you can go ahead and make a read replica in each region. Just like that. And let's go ahead and space it out a little bit. Probably want to do this. Make this one extra large actually, and then we're going to copy it. That is now going to be 3.3 for geographically distributed. Let's draw our little arrows for the replicas. So we have, I don't know if we even need to have these here. We could even just go, we could just omit these and go straight to these replicas instead of having this intermediary here. But, you know, two different options. This one has 3 replicas here. And then this is like a replica to begin with. I know. Is it really necessary? I don't know. Here's another approach. Here, and I'll spare you guys the boredom of watching me draw out the whole thing. So it's like, etc. for these last 3. And And then, you might have a guy that's in the top that is doing one over here in this region. Let's say this guy's in the middle bucket. So he's going to do the big O of 1 check over here, and then he's going to do the log of n check over here. And then this guy's in the first bucket as well. And so it's going to be a single big O of log n check on that. So that is 3.3 geographically distributed. So, okay, we did the Redis sorted set. We talked about making it more available. We talked about geographically distributed. I do need to get through your comments. Yeah, okay, this is actually a good time to get through that. Let's go ahead and go through your comments right now. Somebody said, is the GSI on ranker points? And that was for the earlier thing on DynamoDB. It was for this one. It's on points. Yeah, very key distinction though is rank versus points. Points is just the thing that it's computed and you just write to one record. And it doesn't change the ordering of all the records. The ordering of the records is what's the rank. So like your points is an individual thing of you relative to another player that gets changed just between those two records. While the rank is like the sorting, it's your count across thousands of records. Yeah. That's an important distinction, though. Yeah, it's a very important distinction. Are we computing rank at leaderboard service? Yes. It is. It's yeah. So it's you do a big O of 1 check on this one to get the number of records in that instance, and you do log of n to get your place within the second one. You just add the two together. Okay, looking at the YouTube chat now, we're considering, okay, I did the geographic zones one. In scatter gather, why can we have CDC on all the shards and only send top 100 players? Well, it actually depends on, well, even if it's low volume, it's that if you're looking at a record like and that's rank, not points, it means thousands of records over the wire, over the network. That's the proper word for it. And so that's bad. It has to transfer data. It's doing this like merge of thousands of records like over your internet connection. Most databases are IO bound, and so you want to cut down on the amount of stuff you're sending over the network. When you're sending lots and lots of stuff over the network, that's really bad for your database. You generally want to try and keep everything as local as possible when you're working with your databases. So for example, with Spark, whenever you have to do a shuffle in Spark, that's where you get bounded on that's what slows down your Spark operation. So e.g. Spark shuffle operations are those are performance pain points. And they're very analogous because that's where you're shuffling thousands of records over the network as well. It's analogous. Yeah, I'm trying to explain that as best as possible, but yeah, it's like a shuffle operation from Spark. was primary index and GSI columns in DynamoDB approach. Yeah, so we went over that a little bit. The where's my global? There it is. Okay, there's my global secondary index. Did I not actually? Yeah, I didn't label that properly. This one's a global secondary. This one's the partition key and sort key, and that so that is there's no sort key here. I don't think I ever had a sort key for any of these. It's not, oh, it's not it's a local secondary index, not a sort key. God, did I write that in the other ones? It's not a sort key, it's a local secondary index. My God, sorry. Here, I'm just going to copy this whole thing and paste it over them so that anyone reading this afterwards is not confused by it. Local secondary index. Index, not key. It's not a key. It's a secondary index. And there was no sort key in any of the other ones. And it's so that means this whole thing is just the primary key, the primary index. Why not create a separate DB which maintains a prefix of the n highest ranked players, and on each write, update this DB accordingly? I think that's kind of what I was doing over here with these approaches from approach 2 and 3, is just caching the top 100 players only. So what if you're supporting both use cases of the your page one and the top K players one? So you could actually do one of these ones where you would switch to one business logic or the other, depending on whether it was the top 100 players that you were checking or if it was your page that you were looking at. And so what you can do is that you can actually take Alex Shu's thing, this thing. So you have if you're going to do a hybrid approach, I'm going to call this approach. Well, so we got 3 of each approach, and so now we're just going to call it approach 7, which is so we're going to do both the caching for, what is it, your page. So we've got this thing for your page, and then we also want to have, I want to have the redundancy thing. I still need to have this redundancy thing. It would be stupid to not have that. All right, there we go. Now we got our redundancy, and we have this, and then we're also going to have our cache, which we're going to put over between these things. So it's going to be a separate thing that's also getting updated over a DB trigger. So we're going to just go ahead and use approach 2 from variation 1. Let's just go ahead and like scoot all of this stuff over to the left more. I wanted to have my hybrid approach between these ones. So I was gonna steal from this and not do my weirdo code deploy sidecar thing. I'm just gonna have nope. Just gonna have this. I'm gonna copy that. I'm gonna stick it over here. And then this thing's just going to have some special business logic encoded in it, where if it's a top 100 player, that if it's looking at the top of the leaderboard, if it's just doing that instead of the your current rank thing, it's going to query this Redis instance instead, which can have read replicas. Again, we can do read replicas just like we had over here in approach 2. Be horizontally scaled out with read replicas, and it'll just check that. Otherwise, if it's not the front of if it's not the very top of the leaderboard, you're going to instead do this. So it's the hybrid approach. Yeah, okay, let's look at some other comments from you guys. Hopefully this whole thing is not looking too crazy yet. Here, I'm going to go ahead and give you guys a link to the current Excel draw so that where to link, copy the link, and here it is. Okay. Looking at your other chat comments though, where is okay, there's the prefix thing that you said, as long as in, oh, I think you had more to say about that, as long as that is sufficiently small. Here, I'm just pasting all of yours in. As long as n is sufficiently small, we don't need to distribute the database, and even so, this could be manageable. So yeah, that's where I was going with this, is that like you can go ahead and store that front page of the leaderboard, the top 100 or even 1,000 players, just over here. Keep it cached, and then if you're looking at your page, if you're ranked 10,000, then you would go over here. It's not fault, yeah, and it wasn't fault tolerant. That's why I have this one. That one's the DynamoDB instance to add some fault tolerance to it. I don't think it's distributed. I don't think it's a distributed linked list. I think it only works locally. And so that's why you have to do the big O of 1 check against these first ones. And then you would have your linked list over here. It's not truly distributed. You have to make it distributed yourself through sharding. So with annually sharded, not quite distributed. But this the skip list is cool though. That's actually so hard to find anywhere. Not a lot of databases do actually support skip lists. I'm curious if it doesn't actually work on hard disks. You actually can't do KV lookup on hard disks. You can't do a KV style lookup on a hard disk. That's why DynamoDB doesn't have you can't do a hash table index in DynamoDB. There's no persistent storages that have a big O of 1 lookup. Redis has a big O of 1 lookup because it's in RAM. There's nothing that has persisted big O of 1 lookup though. And so I'm curious if skip lists are similar and you can't actually represent them properly on disk and they only work properly in RAM. That'd be very disappointing. Otherwise, I'd love to see it on DynamoDB. I'd love it if DynamoDB had a skip list in there or something. It doesn't have R trees. It doesn't have quad trees. If it had skip lists, though, that would maybe make up for it in my book. Is there a schedule to these live streams? Yes, it's for the last 6 months, it's been almost every single weekend at 10:30 p.m. PST, 11 a.m. IST. Yeah. And that's on my page on the YouTube channel. And I also post about it in the Discord group. So again, another reminder to join the Discord group. I do actually get back to people on there pretty well. I don't get back to the YouTube comments very well, but I do get back to the Discord. stuff that's tagged me. Sometimes it takes me up to like a week to get back, but I go very far out of my way to actually reply to people. Alex Shu doesn't really get back to people on his Discord, but I go out of my way to try and get back to absolutely everyone. Anyways, next question. Are we designing only one game? How would we handle for multiple games? I mean, I guess that's a valid variation. I guess that's a valid way to kind of vary this question. It does kind of make me think, would we just go ahead and make a different table for every game? I mean, that would be simpler. What if you have like 100 games though? Would you have 100 tables? I guess that is kind of that just kind of makes sense. If your ELO spans those 100 different games, those 100 different video games, then you wouldn't need a different table, and it doesn't really make a difference. But if you have 100 different video games and each one has its own ELO system, how would we handle that? How would we shard the data? So yeah, it's like I think I can't think of anything that would handle this elegantly without just going ahead and making a different table for every single one, even if it's like 100 video games. I can't think of anything more elegant. So yeah, I think you really would just have to make a different table for every. And in practice, so for games like League of Legends, World of Warcraft, Overwatch 2, I think Blizzard owns both Overwatch and it's Overwatch and World of Warcraft at minimum. But I would imagine in their video games, even though it's the same company, maybe they reused like the way that they set up the systems for handling it. But I'd imagine that they did actually make two different copies of a table, and they're not just reusing the same table across both the video games. So yeah, I think you would really just make a different table for each one. Sign feels very iffy due to data corruptions. How can we ensure we aren't propagating faulty data over synchronizing data over regions? So for this one, so with the ordering in which we were like making so the ELO point would definitely be correct. You would definitely, so like the ELO thing is very isolated to a singular record. Your ELO points is very isolated to a single record. And so then when it updates in one database, you're going to propagate it to the other ones. And so then that shouldn't really result in any kind of issues there. How else can you have faulty data? Maybe on the sorting. So like you can have some race conditions kind of happen, and so your rank's not going to be exact. Oh, that was a variation we haven't covered yet, is what if you wanted to have non-eventual consistency? You wanted to have that very brief, like transactional, momentary, ephemeral, exact ranking of yours, even if it's just for a millisecond for a single transaction. How would you handle immediate, strong consistency? And I think that's maybe the only thing we haven't gotten to yet. I do see a couple more comments in the Zoom chat, but I'll get to those later. I want to see if this is all I have left from the things that I'd already like kind of committed to for this session. Top K players, scatter, gather. I did do that. Yeah. Your page, Alex Shu's thing, and I think I did even explain scatter gather over there. So it was that's why I did this thing. And then we had accuracy of the players, rank, exact rank at current moment versus profit. That's what you're kind of doing here. These are kind of like the same, these are kind of saying the same thing. And regular scatter gather of the EVO. With DynamoDB. Yep, I covered that. Global secondary covered it. Skip list. I think this is really just the last thing. And so that would be answering your question though, is if we try and do something that has the immediate exact value to it. So one cop-out answer is, of course, that you just throw a spanner at it, which, I mean, Google will be like, yeah, thumbs up. And so it just uses, what is it? It would use multi-version concurrency control with like, multi-version concurrency control. And then for your transactions, just doing the read operation off of one specific version that your transaction is involved in. Transaction is globally ordered relative to other ones, and then your read just operates over the record that your transaction wrote. But Spanner is a cop-out, and it's very lame. I don't like Spanner. It's a very overpriced, bulky, hardware-intensive way of accomplishing things that can be accomplished without it, I feel. So immediate consistency, though, because this one's doing that. So you can, if it's lower volume, you would of course just do PostgreSQL. So you can just go ahead and do your read directly off of this thing. And you don't want to do that eventual consistency thing. You could also have, so if you have Redis with these things, you can do anchors on Redis. And so then when you do your, when you get it into the proper thing, you can also do a transaction to read it off of that same thing. And you'd of course have some pretty rightful concerns of fault tolerance and reliability. You can have some replicas. So if you have a Redis cluster and you require at least one synchronous replica, even though they're both in RAM, if you have two that are, and if you have two and one of them is a synchronous replica, I think that would really cut down on the amount of fault issues that you'd have. You could make one, you could have your read replica as a persistent database. So what if you went ahead and you were using this where you were doing your transactions against Redis, you're able to do transactions in Redis, and then you just had your read replica in PostgreSQL. So your read replica is PostgreSQL in this case. Well, okay, instead of doing that, let's go ahead and copy. So you have this and you're flipping it so that your CDC happens off of Redis. Like that. And so you would be doing your update to the ranking immediately instead of having the ranking happen as a eventually consistent thing like you have over here. Since it relies on CDC over here, this one would be the only one that would be able to serve strongly consistent reads, which it doesn't provide rank in a scalable manner. Well, over here, if you did that, and then you had a synchronous replica of whatever the heck this is, well, I mean, I guess you would, yeah, you could get away with making it asynchronous in order to improve your latency a little bit. Although I guess that's not really necessary. We're only really trying to solve higher fault tolerance, and having a synchronous replica that has HTTP persistence would solve that issue. So we have Redis, and we're doing a update right there. So what if it was, in order for it to be a immediate consistency kind of thing, what you're doing is you're actually combining these two services into one, technically. And then with your transaction, you're going to first, this would be a transaction, and it would you'd do one call to the database with your transaction operation. And it would do two things when it hits this with its transaction. The first one would be the update, and the second one would be the read of the rank. I think in Redis it's called a anchor. So it'd be one, update the record. Two, get rank. You guys can't read that. I'm sorry, I'll zoom in. Get the rank. I think that's like Z rank. Is the name is how you actually run the command in Redis is Z rank, get rank of the record. And you do that in one transaction. And so then on updating it, you also get back the rank of it, and you're going to send that back to the client. And so it'd be a strongly consistent view of your exact rank in that ephemeral moment that becomes stale like the very next millisecond, because if you're handling like 10,000 TPS, it's like immediately invalid. And I guess you would need to do the big O of one read off of this. God. And then if it's at 10,000 TPS though, it's again, it's like invalid as soon as you're done reading it. And so then it still is off by a little bit on the rank. But this would be a lot closer. If you're able to hold the entire player base in a single Redis instance on one of those 200 gigabyte servers that AWS has, you wouldn't even need to do the big O of one call. So like I was saying, you would first kind of need to do that big O of one request against that one, and then you would have your transaction, which is like, then it's not 100% accurate of what your rank is. Like I said, first, big O of one, check of records in first partition. So it's not like 100% accurate here, but again, what we're going to do is this, and then we don't have multiple shards. We just have one really, really beefy shard. And I can't think of any other way that you'd be able to pull that off than this one. It's going to be approach 8. Strong-ish consistency. It's not fully consistent. And then we have approach. No, why did it not update the, what are you doing? Where's the approach 9 strong consistency for the rank. Here you go. And it relies on that 200 gigabyte beefy mainframe. But yeah, I don't know how else you can do that. I'd love to see some comments or something from somebody about how else they would achieve it. I think I have a couple more comments, then we can close this out. I see, what about if the game itself becomes super hot? I know we are partitioned on player ID, but we may want to compute leaderboard at game level. So you mean if there's multiple video games, then again, like I said, you would have a separate table for each video game. Do you mean like at the you mean like after every single update of like a round within a single video game completing? That's what this has done. That's what I've been trying to do this whole time. That's what I've been trying to do this whole time. Like our query will be for this game given all ranks. What do you mean by manually sharded? As opposed to automatically balanced like DynamoDB. So DynamoDB does partitioning. It like provisions, it does automatic provisioning. As opposed to if you're using PostgreSQL, you'd have to manually provision the number of machines plus what the key set is for each of the machines. Yeah. DynamoDB just figures it out for you. You don't have to know how you don't know how many machines there are. You don't know what primary keys are handled by what machine. DynamoDB just handles it all on your behalf. So when I'm talking about manually sharded, I mean like PostgreSQL, where you'd have to manually assign a certain number of machines to your horizontally scaled out thing and manually specify the key set. You'd probably also have like some kind of weird business logic you had to roll yourself for routing the proper request to the proper machine, which is absolutely massive pain in the ass. Transaction would be serious bottleneck for scale because all the updates will stuck and also, if you use MVCC, multi-version concurrency control, you would be able to you would have optimistic optimistic locking. I think you actually have you don't have the way that you're resolving the transaction actually doesn't become a bottleneck for the later transactions. They're all actually able to run on top of each other. I'd recommend checking out this term though, multi-version concurrency control. It's used also for implementing causal consistency. It's really great for if you look into isolation levels, you should definitely check it out. I think it's talked about a little bit in the isolation chapter of Martin Kleppmann's book. You wouldn't have to have your transactions blocking each other though. One of them would just kind of be working on stale data, but it would be consistent to that copy of the data, which is like if it's only consistent for half a millisecond, a human can only process information at like what 20 hertz, maybe 100 hertz, which is 10 milliseconds. So then it's literally updating faster than you're going to be able to process it as a human. Yeah. Okay, I think I've answered everything. I'm pretty happy with what we've covered. This handled my goal of what I wanted to cover. We got a lot here. I'm gonna again give you guys a link to our final diagram here. So here's the final diagram in the chat. I'm going to edit the description of the video right now to have it. There. So if you update the page, if you refresh the page, it should actually have the final diagram on it right now. I'm actually testing that. Yep, it's in there. So right now, oh God, please no. All right, there we go. Now we can wrap it up. All right, thanks for joining me, guys. I hope you had fun. I hope you learned something. I hope you enjoyed this. I hope to see you next week. I will keep you guys updated on what the heck my plan is for how the time is going to change for daylight savings. I did say it'll just slide forward by an hour for the US. Having some second thoughts. Also, please check out the website, which is systemdesignfightclub.com. Not even indexed by Google yet. All right. Thanks again for joining me. I'll see you guys next week. See ya.